Hello, I'm Elvis Liu. So, yeah, as Julian said, I'm the principal engineer and AI team lead at Tencent Games. My presentation is about a project called F.A.C.U.L. It's an AI companion in FPS games that understand human language. I have presented a similar topic at GDC this March. So, has anyone attended my talk? Okay, thank you, thank you. Uh, right, thank you for that. So my materials has been updated, but I'm still using the Tencent's GDC template. So let's start with watching a launch trailer from last year's Gamescom. For those who haven't seen it, you are in for the treat, and for those who have, it's worth for another watch. Okay, that was our launch trailer. Okay, today I will begin by giving some background information about F.A.C.U.L and discussing why voice communication between human players and AI is not just a gimmick, but necessary. Next, I will cover the four major modules of F.A.C.U.L system: voice input, intent recognition, scene recognition, and TTS. Finally, I'll conclude this presentation with a discussion and invite your thoughts and questions. So let's start with some background information and explore why F.A.C.U.L is created. A bit about myself, I got a PhD in computer science from the University of Birmingham in the UK. At the time, I specialized in building large-scale simulation systems. Then I went to IBM Ireland to do some pioneer research in exascale supercomputers. After that, I became an assistant professor at NTU Singapore. I taught courses in computer graphics, VR, game development, and modeling and simulations. And then I joined Tencent in 2020 and became an AI team lead. Now, let me give you some background on F.A.C.U.L. Traditional first-person shooters have limited human-AI interaction to basic commands like attack, follow. This is largely due to the constraint of existing input methods such as hotkeys and command views. These limitations prevent players from issuing complex instructions like clear the second floor or take cover behind that tree. For the first time, Arena Breakout Infinite, developed by Tencent Games, enables players to interact with the AI companion F.A.C.U.L using natural language. F.A.C.U.L understands complex instructions, provides feedbacks, and performs a series of tasks. It can identify thousands of in-game objects, including buildings, vehicles, and collectible items, and accurately distinguish different colors and materials. This revolutionary feature offers players the most immersive experience yet, allowing them to collaborate with human-like AI. So actually, voice control in FPS games is nothing new. 20 years ago, we have a game called SOCOM. Anyone play SOCOM before? Wow, quite a few. You're from the older generations, like me. Okay, SOCOM allows players to use voice commands to interact with NPC teammates. In 2023, a voice command mod was introduced for Ready or Not, enabling even more sophisticated tactical collaboration with NPC teammates through voice control. But these games are pre-LLM. They require players to give instructions with exact wordings and do not support small talks with the AI. So also, the AI lacks the ability to recognize and interpret scenes in the virtual world. So is voice control a gimmick? Is it necessary? To determine if voice control is just a gimmick, I would ask one question. Can voice control be completely replaced by other input methods like hotkeys, command views, or pull-down menus? If voice control can be completely replaced by other methods, then it's just a gimmick. Otherwise, it is necessary. So you might wonder, what scenario makes voice control irreplaceable? I would say voice command with targets. For example, hide behind the red truck or clear the second floor. So given the numerous objects and locations in a game, in our case, we have more than 17,000 in-game objects in just one map. It's infeasible to use hotkeys, command views, or pull-down menus to specify these targets. So of course you could type, but typing is very slow in an action game. So in this case, voice command becomes the only method to efficiently communicate with AI teammates. So if the AI cannot identify locations and objects in the scene, the player cannot give instructions with targets. AI's scene recognition ability becomes an important element to make voice control necessary. So F.A.C.U.L is not just the first FPS AI companion that understands human language. It is also the first AI NPC that has the ability to understand players' description of the virtual environment. This is what makes F.A.C.U.L better than those pre-LLM FPS AI. So F.A.C.U.L draws inspirations from action movies where assault team members work together seamlessly to achieve their mission goal. The tactical communication is quick and precise, while talking to an AI assistant like Siri is one thing. Engaging in tactical communication with an AI takes it to an entirely new level, showcasing the advanced capabilities of our AI technology. Of course, we can do it for RPGs. Like I can command the paladin, tank that dragon, or tell the wizard, nuke the beast. Then paladin goes in position, and the wizard goes, roger that, casting. Well, of course, we can do that, but it doesn't give you the same sense of quick and precise tactical communications like those of the FPS games. So that's why we do it for Arena Breakout Infinite. So the production team gave us some high-level objectives for the F.A.C.U.L project. First, we need to build an AI system that allows players to interact with AI companion using natural language. Second, the AI should be able to provide tactical collaborations and give real-time voice feedback to the players. The goal of having an AI teammate is to avoid the negative aspect of teaming up with random players who often fail to offer the same level of collaboration required. Ultimately, we aim to create a new type of gameplay by integrating AI companion. I'll come to that later. So we have set a number of requirements for the F.A.C.U.L project. First, a player can control not just one, but up to 3 AI companions in a team. This allows for more complex team collaborations. Second, it must support continuous speech recognition without the need of trigger words like, hey Siri. This ensures a more natural interaction. To achieve this, the system must recognize the player's voice only and perform noise reduction. As the most important feature of F.A.C.U.L, the AI should be able to identify thousands of objects and locations in the game. It should differentiate different colors, materials, and specific features. For example, red truck, timber truck, or metal door. Also, the AI should be capable of executing a sequence of instructions, such as check the second floor of the motel, and then come back to the front yard. New instructions should be able to interrupt the previous ones. Voice feedback should be diverse and support limited small talk. I'll come to this topic later. Here is how F.A.C.U.L works. We start by getting voice input from the player, which is then converted to text by an ASR model. Next, we use fine-tuned LLM to analyze the player's intent. After that, a multimodal LLM performs scene recognition. The game engine then executes the instruction, and finally, we use real-time TTS to generate voice feedback. Okay, AI geeks, this is for you. I'm going to talk about the technical details. And for those non-AI geeks, I'm going to bore you with AI tech details for the next 20 minutes. So let's begin by exploring how we convert the player's voice input to text. So our voice input module consists of 2 main components, the client side and the server side. On the client side, the device captures voice input as raw audio signals. These signals undergo 3A processing. That is acoustic echo cancellation, automatic noise suppression, and automatic gain control to enhance audio quality. Following this, the F.A.C.U.L process isolates player speech by filtering out background noise and silent segments. The processed audio is then sent to the server side for further analysis. On the other side, the speaker recognition system first eliminate non-players audio. The ASR model then converts the speech to text to address potential recognition errors. We implemented an LLM-based ASR error correction mechanism that leverages context and knowledge bases for precise adjustments. Finally, the corrected text is forwarded to the NLP module for intent recognition. Oh, let's skip this. The second module is intent recognition, which is about how the AI understands players' instructions. We implemented a fast text processing module to quickly filter out on non-technical content. Bird feed is used to recognize technical instructions. For more details of Bird, check out the Google paper about Bird. We then use a domain-aligned LLM to handle complex technical instructions involving contextual references and ambiguous semantic reasoning. As mentioned earlier, one of the F.A.C.U.L requirements is to perform continuous speech recognition, which poses a significant challenge. The ASR process test often contains a substantial amount of noise and small talk. If a large-scale language model is used for this task, it can significantly impact real-time responsiveness, as processing the noise and small talk requires considerable computational resources. To address this issue, we implemented lightweight models to handle the task more efficiently. Specifically, we integrated fast text to classify data into small talk and tactical communication, streamlining the process and reducing computational overhead. This solution greatly enhanced runtime efficiency and improved response time. To segment players' command into a sequence of actions, we have designed a multitask labeled structure for the executable actions. Involves command segmentation, intent classification, and named entity recognition. In this example, when a player issues the command, hold position at the red door, I will grab the loop. The Bird model can understand and output the intent as move and the target location as the red door. As mentioned earlier, we rely on Bird as the pre-training representation model in the feature extracting layer. In the downstream task, we introduce commands segmentation to obtain executable subcommands. The named entity recognition can be regarded as a sequence of classification tasks, which can utilize the conditional random field, or CRF, to consider the context information of input sequence. The attention-aware feature aggregation mechanism is introduced to form new features. These newly formed features will serve as the input for the subsequent hierarchical intent classification. Since LLM are very good in generating Python codes, we adopt a code-centric approach to control AI NPCs. We design a series of NPC actions, for example, move, attack, open door, which are represented as Python functions. The LLM planner generates Python codes to call these functions to control the target NPCs. In this way, their actions would be more reasonable, even if the tactical tasks are complex. For the game's low cost and fast response requirement, a lightweight LLM is more suitable than generic large-scale LLMs. After all, our AI companion doesn't need to know everything about the world like ChatGPT. It only needs knowledge specific to this particular game. We fine-tune a lightweight LLM using tactical communication to align with the dialogues of real-life companions. First, we obtain the desired behavior of NPC by generic LLM and labeler for supervised fine-tuning, or SFT. Next, we rank multiple output generated by the different models using a labeler or DPO alignment. The intent recognition module in F.A.C.U.L integrates three models. Fast text intercepts the majority of the small talk, while BERT efficiently forwards low confident instructions to the LLM for reasoning. This significantly enhances command accuracy to 88.6% and improves the system's concurrency to fourfold that of a pure LLM system. Our solution reduces inference deployment cost by approximately 75% compared to a pure LLM system. As I mentioned earlier, scene recognition is the killer ingredient of F.A.C.U.L, which is about how AI understands players' description of the virtual environment. The scene recognition model has two main processes, data set preparation and runtime process. First, we use an in-house PCG engine to create game levels for Arena Breakout. During the generation process, it assigns many labels to the game assets. These labels serve as referencing points for comparing similarity during runtime. The runtime process includes a similarity search to identify specific in-game objects. For instance, when a player asks the AI to search for a red truck, the AI can precisely identify and locate the truck the player is referring to. This table shows the structure of our game access. The access, image, and labels are used for similarity search. Its location is used for AI navigation. Its rotation helps for AI to understand the physical spatial relationship. Its bounding box is used for AI to perceive the size and range. Finally, its cover points guide AI to find more reasonable cover position. Here is an example of how a similarity query is performed. To search for a blue car, we begin by tokenizing the query text and comparing the similarity of individual tokens. In this case, the query consists of two tokens, blue and car. So next, we embed the query text using clip and calculate the text-to-image similarity. Finally, we aggregate all the scores to compute the final similarity score. So when you say hide behind that tree, what exactly does that tree means? Our system searches for entities by evaluating similarity, distance, and rotation. In this example, entity 3 has the highest similarity score, but is located very far away. Entity 5 is the closest, but it's not within the player's field of view. Meanwhile, entity 1 achieves the highest overall ranking after considering all factors. So therefore, it is selected as the final search result. So when handling complex hierarchical search requests, the system searches for the next entity based on the previous entity in sequence. For example, in the command, go to the car on the left side of the sandbag. The system first identifies the sandbags using the player's location as a reference point. It then uses the sandbags as the base point to locate the target entity, the car. So if the target entity has cover points, the system selects the optimal cover points based on the player's location and orientation. The scene recognition module in F.A.C.U.L combines a text similarity model with a fine-tuned clip model, which effectively increases accuracy to 96%. It also achieves 4 times more query per second than the pure clip system. Our enhancements has led to a cost reduction about 80% than general baseline. Okay, the final module is TTS, which is about how AI gives voice feedback in real time. Our TTS system generates 3 types of feedback. The first is instant feedback, which happens immediately in response to user command. For instance, if I ask the AI to open the door, it replies, Roger that. Or if I ask, how's the weather today? It responds, it's a sunny day. So these are examples of instant feedback. The second type of feedback involves response given after the AI completes the task. For instance, after hiding behind a tree, the AI might say, in position, or after locating a green box, it could say, found it. The third type of feedback is dynamic and is not triggered by user command. Instead, it's driven by game states. For example, if the AI detects an enemy in the dining room, it says, contact dining room. Or if the teammate is down, the AI reports, Echo 2 is down. These types of feedback is based on the changing states in the game and provide valuable updates to the players. To minimize AI response latency, certain common phrases such as copy that, reloading, or tango down are pre-generated offline and stored in the voice package within the game client. All other voice feedback, particularly non-tactical responses, is generated in real time by the online TTS service. To further minimize response time and reduce the workload of the TTS server, we implemented a cache approach to store the most common phrases. When a TTS request is made, the service checks the cache and returns the stored audio data if there's a cache hit. If no match is found, the TTS service generates new audio data to fulfill the request. This approach significantly reduced the demand on the TTS service. According to our statistics, approximately 95% of TTS requests result in a cache hit. Okay, I have finished all the contents for AI Geeks. So we have made a demo for last year's Gamescom. It's a bit long, 8 minutes, but let's watch it. Okay, you like it? Right. Right. That's not all. Let's talk about some design consideration and future work, and then I will wrap up the talk. An interesting thing happens during the production of our demo you just saw, which makes me wonder if AI makes the same mistake as human. Should we correct it or not? So in our original demo, the player asks the AI teammates to hide in the grass as there was visible grass in the scene ahead. You can see the grass there. So AI companion recognize the grass, comply with the command, and successfully hide in the grass. No one in the production team saw any problem with this command. But after we produced the demo, the original one of my friends noticed something that almost everyone has overlooked. What we thought were grasses were actually bushes, as they had woody branches. Okay? This means that our entire production team had make a mistake, and the AI companion performing entity similarity search by using multimodal LLM, whatever, had also made the same mistake. Okay? This raises an interesting question. Should we correct this mistake? Should we make this AI better at scene recognition than the majority of human players? What will you do? Okay, in the end, we did correct the mistake, but I still believe this is an interesting topic worthy of deeper discussion, right? And the majority of tactical instructions are very specific, but should we support high-level or abstract instructions? If clear the living room is fine, should we support clear the second floor? If that's also okay, what about secure the whole building? And what about clear the whole map? Okay, so if we support clear the whole map, would players just stand there and do nothing for the entire game? Where's the fun in that? So our game designers has extensive discussions about these questions. It's an open debate, but we obviously do not want to take away the fun for players. So we will never support clear the whole map. Okay, so currently we are 95% ready to deploy, and we're waiting for the production team's deployment schedule. We have been conducting large-scale tests since last year to find more bad cases. We are also trying to reduce response latency. Hopefully, we can cut the latency of the ASR model in half by next month. We have launched a trailer of the Chinese version on the Bilibili website within China. We are also working different ways to deploy the LLM on the mobile phone client. This is difficult because the memory consumptions of running an LLM on a phone is huge. So we need to find a way to reduce it significantly. I'll show you the work in progress later if you want. Finally, we have submitted a paper to NeurIPS, a top AI conference. If it gets accepted, we'll also publish a preprint version. So since the beginning of the FPS genre in the 1990s, it's been very rare for a new technology to drive a new type of gameplay. Has anyone played Wolfenstein before? Wow. You're all from the older generation. So you know what I'm talking about. So while advancement of computer graphics technology have greatly improved visual effects, nowadays Battlefields and Call of Duty look much, much better than Wolfenstein. But they have not fundamentally change how we play the game. So of course, there is one exception, the advancement of network technology, which enable the creation of multiplayer FPS so that you can fight against or collaborate with other players through a network. Now, could Gen AI be the next driving force in gaming? For example, players could lead a team of AI-controlled NPCs and venture into a dark zone to compete against other players. You could instruct one AI sniper to serve as an overwatch, stationed on top of a building, while directing another to flank the enemy. So this could introduce an exciting new game mode, combining the elements of FPS and RTS gameplay. So many people have asked me whether this tech can be applied to other genres. The answer is absolutely yes. The first genre that comes to my mind beyond shooters is open world RPGs. Imagine you can walk around a city like GTA and talk to everybody using natural language. And through these conversations, you could ask NPCs to perform tasks or advance your story in meaningful ways. That would be super cool. We are also exploring the possibility of selling this tech as a service or even make it open source. All options are on the table for consideration right now. Okay, that's it for today. Thank you all for coming to my talk.